Welcome back. We're going to be looking for the measures of some angles in arcs in circles, and this is our first relationship, and that's the measures of central angles. We're going to find the measures of some other types of angles as well, including inscribed angles and angles that share the same arc, and tangent chord angles, and angles that are formed by intersecting chords, and angles outside the circle. This is our first relationship, though. Just as a reminder, a circle is a set of points that are equidistant from the center. To help you out, I also put a little word notes at the top anytime there was something that you were going to be adding to your notes. And that first thing is, with the star there, the total number of degrees in a circle is 360 degrees. So fill in the missing words in your note template. And then a definition for you, arc of a circle. So the arc of a circle is two points on the circle and the continuous unbroken part of the circle between the points. So we have two different arcs here. We have one arc that is shown in green. We have another arc that is shown in red. And we're going to learn how to name those arcs, and we're going to learn how we can classify arcs based on measurement. And waiting for the page to turn. There we go. All right, so angles are grouped into three major descriptive categories, right, and it's based on the size of the arc. And this is filled in in your notes already. So a minor arc is less than 180 degrees, a major arc is more than 180 degrees, and a semicircle is exactly 180 degrees. Right? So half of the circle, that's a semicircle. If you're more than half, you're a major arc. If you're less than half, you're a minor arc. So in the picture there, we have a major arc and a minor arc. All right, we have the major arc is arc NKH, or I could call that HKN. And the minor arc is arc HN, or I could call that NH. Notice that we use, and you can fill that in your notes there, 3 letters to name a major arc and distinguish it from the minor arc. Because if I were to call them both NH or HN, I would have no way of knowing which arc you meant. Did you mean the shorter distance, or did you mean the longer distance? So if we include another point with a major arc, it tells us to go the long way around the circle, not the short way. So every time we have a major arc and we want to be, it's more than 180 degrees, we're going to always use 3 letters. Right, so it doesn't matter if there are lots of points. It could be any point on that arc, could be the center point, but the first and last point always has to be the end points. Right? The order of those end points doesn't matter, but the end points are the first and last letters, and another point, any old point along the way, is the middle letter. Okay, so that's how we name arcs. All right, so let's identify the major and minor arcs in the circle below. All right, so we have a minor arc. I'm going to do the minor arc first. The minor arc, I could either call that arc AC. I can't see anything, there we go. Or I could call that arc CA. The ordering of those 2 letters doesn't matter. Those are the endpoints of that purplish, pinkish fuchsia arc there. Right? We have another arc, which is the rest of the circle that's not that fuchsia color. Right? And for the major arc, I have to use 3 letters. So I can name this arc ABC if I want to be alphabetical. And if I don't really care about being alphabetical, I can go the other way and call this arc CBA. But notice that B has to be in the center because it's not one of the endpoints. A and C are. So A and C have to be on the outsides, or the endpoints. Right? And so it's not that difficult to name. Oh, we just put the symbol for an arc. Well, it looks like an arc. There's really no other way to describe it. So anytime we're naming an arc, to distinguish it from a segment or a line, we'll put that symbol. And this is in your notes at the bottom there. And a little fill in there, and it's in red for you. So formulas for angles in circles that are formed by radii, chords, tangents, and secants. And this one is going to be formed by radii. All right, so a central angle is an angle formed by 2 intersecting radii such that its vertex is at the center of the circle. All right, so if it's red, you probably need to write it down. Oh, with the exception of the word at. At does not need to be filled in. It's already in your notes. But everything else you can fill in there in that definition. All right, and then we have a picture. So the formula for a central angle is so easy. The word intercepted arc. Intercepted arc means that it's the arc that's between the two ends of the angle, like the two arms of the angle or sides of the angle. So this right here, where my pen is writing in blue, this is the intercepted arc. Label that in your notes, intercepted arc. And my C and E are so close, it looks like interrupted arc or something. So it's there we go, septed arc. Okay. And right here, X is the central angle. Right? So its position gives its name, right? So it's at the center of the circle. Its vertex is at the center, so it's called a central angle. That makes a lot of sense, right? Intercepted arc, like you have an interception, right? You get in the way there. You catch the ball, right? So think of the angle as kind of going through the circle there and capturing the arc in between the two sides, if that helps. So angle AOB here is the central angle. Its intercepted arc is the minor arc from A to B, and the angle and the arc are the exact same length in degrees. So I shouldn't say length. Length is different. Exact same measure. Exact same measure in degrees. They are exactly the same. Right? So the measure of arc angle AOB is exactly the same as the measure of arc AB. So it's pretty easy to work with central angles because they have the exact same measurement. And we're waiting for the page to turn. All right, so what is and what is not a central angle? So a central angle is an arc, a central angle, and arc is the measure of the central angle. So the central angle and the arc and its intercepted arc have the exact same measure. All right, and so, well, some of these are central angles and some of these are not, right? So the definition of a central angle is an angle whose vertex lies on the center of the circle. The first one looks good. Vertex is on the center of the circle, right? And its sides are formed by radii. The second one looks good. Central angle. The vertex is at the center of the circle, and radii form the sides of the angle. The third one is not a central angle. The vertex is not at the center of the circle, and those are not radii, those are not chords, those are nothing. All right, so that's not a central angle. All right, so make sure that when you're going to use the formula for central angle, that you actually have a central angle. All right, so here we have some information about central angles and their intercepted arcs. And this is in your notes. This is on the second page, or the last page of the notes that we haven't gone over. So a minor arc is the shortest arc connecting 2 points on a circle. The measure of a minor arc is less than 180 degrees, and it's equal to the measure of its related central angle. So the measure of arc AB is equal to the measure of angle ACB, which is X. A major arc is the largest arc connecting 2 points on a circle. So we have the same circle C there, right? So the measure of the major arc is greater than 180 degrees and is equal to 360 degrees minus the measure of the minor arc with the same endpoints. So let's say we knew what AB was and we wanted to find the measure of arc ADB. Well, we could just take arc ADB, the measure of arc ADB is going to have to be 360 degrees minus the measure of whatever arc AB is. Right? So if we subtract AB from 360, we'd have the measure of arc ADB, because together those two arcs make up the entire circle. And a semicircle is an arc with endpoints that lie on a diameter. Right? It's half a circle. Right? So the only thing that cuts a circle in half is the diameter. So a measure of a semicircle is 180 degrees. Right? And it's the same either way. When we have when a diameter is forming our angle, we're going to have a straight angle. So angle ACB here is a straight angle. It's 180 degrees, and AB here is a diameter. And this should be segment AB. Just add my handwriting to your notes at the bottom there. All right, a little information for you. And I don't know if that segment's going to pop up, but just add a segment over the markings for a segment over yours, because mine is not popping up. Let's try it again. It just doesn't want to come up. So you just put it on yours. I'm fine. And we're going to go on. Let's solve some problems with central angles. All right, so here, this one is in your notes. We want to find the measure of the following. So arc CDA, all right? So I'm going to kind of color code it here. Arc CDA is right here. There is that arc. All right, notice we have an angle right here. We know the measure of angle COA right here. Well, that's 115 degrees. And we know that since angle COA is a central angle, arc CDA is going to be congruent to it. So arc CDA is also 115 degrees. All right, next to that arc CDA, we're going to put that arc CDA, the measure of arc CDA, is equal to the measure of angle COA, because that's a central angle. And so it's going to be 115 degrees. All right, so arc CDA equals 115 degrees. All right, arc CEA. So CEA is right here. Starts at C, goes through E. Notice E's right there. And keeps on going till it gets to A. Well, if you notice, the green and the blue make up the entire circle there. So whatever isn't arc CDA must be arc CEA, right? We also have another central angle. It's just going the other way. So this is also a central angle over here. Right? That's a central angle. Right? Nobody says your angle has to be less than 180 degrees, right? Or 180 degrees or less. We have reflex angles, right, that are more than 180 degrees. So that is a reflex angle. Right? So either way, that angle is going to be equal to that arc, or that arc is equal to that angle. And they're both the whole circle minus arc CDA. Right? So the measure of arc CEA is equal to 360 degrees. And then we'll subtract from that arc CDA, which is 115 degrees. So that's going to give us 245 degrees. Right? So, and maybe in your circle, put 245 degrees there, right? Because that angle is also 245 degrees. All right, let's look at the next one. Arc AEK. So I have it written down here, plus I'm kind of abbreviating it for you as well. So notice AK here is a diameter. So let's write that in. AK is a diameter, which means that's going to be a semicircle. So arc AEK, here's my little arc symbol, is equal to 180 degrees. That's half a circle. All right, so number 4. We have arc ADK. So we had arc AEK, and now we want arc ADK. So let's see what's the difference between those two. All right, so ADK is going this way, and AEK is going this way. It's the other half of the circle. But we knew either way it was going to be 180 degrees because the endpoints of that arc were on the diameter, right? So it has to be half a circle, right? So we can basically write the exact same thing for the one below it, except change the arc. So AK is a diameter. So we have arc ADK is also 180 degrees. And the last one up there, angle COK. COK is right here. Right? So, and I'm going to scroll this so you can read at the same time. Maybe. So angle COK is just that semicircle, AOK, minus COA. Right? So it's just that whole thing there. So we're looking at the angle, not the arc. So we will just take 180 degrees for the angle altogether, right? Because the angle and the arc are the exact same measure. And we'll just subtract from it COK to get our measurement. Right? So that means that angle COK is just equal to 180 degrees, which is what angle AOK is, right? That's a straight angle, minus 115, because that's angle AOC, and that's going to give us 65 degrees, right? And there's our measurement. So that's all there was to it. And so let's get to add and subtract a little bit. Right? Not too bad to work with these. Let's continue on. I'm going to finish the central angles in this podcast. I may break it up into 2 podcasts. So maybe I'll do one more, and then I'll take a break and you'll join me again, and we'll do a few more. All right, so we have another one here. This one's not in your notes. We want to find the measure of the following. Arc RP. Well, that's pretty easy, right? We can, and it's a central angle, right? So since our angle RQP is a central angle, arc RP is going to be congruent to it. So arc RP is going to be 110 degrees as well, right? So this is 110 degrees because the arc equals the angle, right? So RP is 110 degrees. It's congruent to angle RQP, right? And let's look at the next one, RS. All right, well, we see the angle measurement there, right? And it's a central angle. So since RQS is a central angle, arc RS is congruent to it. Angle RQS is a right angle, so it measures 90 degrees, and that's the measure of RS as well. So RS is 90 degrees. These aren't too difficult at all, are they? Maybe we'll do some harder ones in the next little practice. Arc RSP, right? So that starts at R, goes through S, and stops at P. Notice that's the entire circle other than RP, right? So the entire circle measures 360. Arc RSP is going to be 360 minus arc RP, so that's going to be 250 degrees, right? So this one was just arc RSP was just 360 degrees minus 110, and so that was 250 degrees. And together those two arcs make up the entire circle. Angle PQS is right here, okay? Not as big as arc RSP because its intercepted arc is PS. Right? So PS there, or arc PS, or angle PQS, is equal to the entire circle minus, we have to subtract angle PQR, and we have to subtract angle RQS. So if we subtract away the 110 and the 90 degrees, we're going to be left with 160 degrees for angle PQS. So angle PQS equals 160 degrees. I won't write all the reasons, since I did on the other one because it was in your notes, so you would be able to have a shorthand way to write it. I have it right below there, so I don't need to write it again. And then finally, arc PS. I don't know what happened to number 5. It's probably hidden under the screen if I move the screen. Yep, there it is. All right, so arc PS is this arc here. Well, that's an easy problem because we found the measure of angle PQS a little while ago, and PQS and arc PS are the exact same number of degrees, so that's 160 degrees as well. And we're done with this one. So I'm going to take a little break, and I'm going to come back and I'm going to finish this concept up with a couple more slides. All right, bye for now.